Hi, I'm Jules Strawberry, and I'm here to tell you why geologists are important to the moon and to all of our space missions, really. And this is for one of my friends that I met at First Robotics competition in Houston, Texas at the World Championship. So this goes out to you, my friend, my little tiger friend. When we went to the moon the first time, geologists had different hypotheses about how the moon was formed. And they saw all these holes in the ground, and they thought there was a lot of volcanoes. I mean, if you look at it, you know, they're tapered up, there's a hole in the middle. It looks like a volcano. And there was all this ash on the ground, or all this gray dirt and grit that looks a lot like the fallout from a volcanic eruption. There were scientists who staked their reputation on this, who wrote big, thick papers on the fact that the moon had volcanic activities. The geologists here on Earth taught the astronauts, most of whom were fighter pilots, how to identify different geological formations, different rocks, different boulders, and to look for different types of rocks so that when the astronauts went to the moon, they could collect a wide selection of different rocks, different geological formations. This was wonderful. This was great and wonderful. However, we did send one scientist to the moon. Harrison Schmidt, who went by the name Jack, was on the very last mission to the moon, Apollo 17. But I digress. We really only had 6 different landing sites for the Apollo missions. 6 different sites. There were 2 main regoliths, regolith being the loose debris between the bedrock and the vacuum of space. So loose debris, think of it like dirt, but and there were 2 main regoliths. One was the lunar mare and one was the highlands. Now this is a simulant, meaning it's not the real thing, it's fake. It's what University of Central Florida's Exolith lab came up with to be pretty darn close to what was on the surface. And why is that? Why did I have to purchase simulant instead of the real thing? Because the real thing is closely controlled by NASA's Johnson Space Center here in Houston, Texas. We brought back, the Apollo astronauts brought back less than 900 pounds worth of regolith and rocks, and those samples are closely guarded for research purposes. So I bought some samples. See that it's very fine powder, and it has some interesting characteristics. And so here on Earth, when you have beach sand, it's spherical. It's balls, little balls, right? And it's worn smooth from the water and the wind. But this simulant and the lunar regolith is actually very jagged. There's no water, there's no wind to wear it down. And because it's so jagged, it can cause a health hazard. That is, if you breathe it in, then it's caustic and it can scrape up your mucus tissues and your lungs. It can hurt you. So we don't want, we want to be very careful with this. You can see that there's a human health hazard warning on the label. And I'm getting it all over myself because it's not closed very well. The regolith actually defeated Velcro, made it not work anymore. The regolith on the Apollo missions got into the ball bearings and wore those down. And thank goodness we only had very short missions. Some of the missions were less than 8 hours. The very last mission, Apollo 17, Gene Cernan and Jack Schmidt were actually on the surface for 3 days, less than 8 hours each day. If any of those missions had been longer, there was a very high risk because of the hazards caused by regolith. And I wanted to show you some more of this simulant because it's just so darn interesting. Now, I've been asked if it's magnetic. There's less than 2% iron in some of the samples that were returned, which means that yes, some of it is magnetic, but not all of it. It's also charged, meaning the sun's rays, the ultraviolet rays from the sun, actually give electrons to the regolith and can charge it up to 3,000 volts. So that's interesting, which means that it can act like static cling. Have you ever opened the dryer and your sock was stuck to your skirt and you couldn't pull them apart? Or it was difficult to pull them apart and it looked like that they were glued together? That's static cling. That's when there are electrons that are holding two different things together through static electricity. So there's some of that on the moon, and that static electricity caused the dust to seem to climb up the spacesuit. So instead of just being on the boots, the astronauts did fall down, but that dust also seemed to crawl. It's not alive, it didn't really crawl, but due to static electricity, it did move up the suit. It also, because it was jagged, embedded in the fabric of the suits. All of this is to say that the geology of the moon is very interesting and that we do need geologists. Oh, let's circle back to what we talked about at first, the volcanoes. When the Apollo astronauts returned the rock and regolith samples to the labs, the scientists were able to see that the rocks were not volcanic rocks, they were breccia. Okay, let's talk about breccia for a minute. When a meteor crashes into the surface, it vaporizes. It's very, very hot due to the friction and the velocity and the impact. And so that meteor mostly vaporizes, but it also causes some of the surface to fly up. And that surface that flies up is called ejecta until it falls to the surface, and then it's called breccia. So breccia has certain characteristics that are different than a volcanic explosion, and that's how the geologists knew that most of those holes on the moon are craters caused by meteor impacts. The breccia has a very interesting geological features. I'll just tell you about one. The iron that was vaporized or melted at very high heat due to the impact of some of those meteors cooled very quickly. So instead of forming the structure, the hard packed crystalline structure that we're used to seeing on Earth, it was cooled into a glassy amorphous structure, and we call those agglutinates. It's very fascinating. To have iron super cooled is just metal. To have a metal that was melted by something hitting something else and then super cool before it fell to the surface is just fascinating to me. So, to my friend on the Tiger team that asked whether or not geologists were important to the space program, the answer is yes. Yes, overwhelmingly yes. We need geologists to teach the astronauts what to look for. We need geologists to study the rocks, regolith, all the things that come back from our missions to the moon, and one day to Mars. Because yes, we are working on ways to get samples to return to Earth from the Mars. We've already packaged up some of those samples through Mars Insight rover that went and collected samples and left them on the surface. So that's something to look forward to. Mars actually has high iron content, and that's why the surface looks so orange, is because it has rusty iron in it, or oxidized iron in it. This is also a simulant, by the way. It's not the real stuff. So thank you for your question from the Tiger team, First Robotics Tiger team. And I look forward to more questions. And if you want to be involved in space exploration, I'd say follow your passion. And if your passion happens to be geology, then you rock. Thank you, and happy innovating, everyone.